In this video, we'll discuss tangents. A tangent is a line in the same plane as a circle that intersects the circle in exactly one point. That point is called the point of tangency. So if we're looking at this line AB, AB is tangent to the circle C at point A. So right here, A is our point of tangency. Segment AB and ray AB are also called tangents. So it doesn't matter if we're talking about the line, which goes both directions, a segment, which has two endpoints, or if we're talking about a ray. If they go through the point of tangency, then they're going to be called a tangent. So segment AB and ray AB are also tangents in addition to the line AB. A common tangent is a line, ray, or segment that is tangent to two circles in the same plane. So if we look below, these lines L are tangent to circle F and G in two different points here, and then the same point on the right. L is a common tangent of circles F and G in both of the figures. The shortest distance from a tangent to the center of the circle is just going to be our radius. Radius drawn to that point of tangency. So if we have circle S and we draw our radius to our point of tangency T on the line of tangency L, then we have our shortest possible distance from the circle to that line. So we have a perpendicular angle here. So in a plane, a line is tangent to a circle if and only if it is perpendicular to a radius drawn to the point of tangency. So line L is tangent to circle S if L is perpendicular to ST. And if it goes both ways, if L is perpendicular to ST, then we can say that line L is tangent to circle S. Let's take a look at a couple examples here. So this first one, JL is a radius of circle J. Determine whether KL is a tangent to circle J. Let's take a look. So if it is a tangent, then we know this is going to be a right angle because it'd be the shortest distance from J to this point of tangency. So we want to see if this is a tangent here. So if it is a right angle, then our Pythagorean theorem would work. We could say that 8 plus 15, 8 squared plus 15 squared, so this part plus this part, does that equal, and since the radius is 8 here, we can say that this part is 8. So we can say 8 plus 9 gives us this whole length, kj squared. So our a squared plus b squared equals c squared. Does this check out? So if we solve this, 289 equals 289. Just like we thought, our Pythagorean theorem works, so we can say that KL, so this line here, is tangent to circle J because we have a right triangle. This one says that JH is tangent to circle G at J. Find the value of X. So in this one, we're just working the opposite direction. Now we know this is where the if and only if comes into play. So now we know that it is tangent to circle G at J. We want to find the value of X. So we can use our Pythagorean theorem again. So our a squared and b squared is going to be our x and 12. So x squared plus 12 squared equals, and then our c is going to be our x plus the 8. That's the length of this whole segment here. Our hypotenuse is x plus 8. So x plus 8 squared. So we have x squared plus 12 squared equals x plus 8 squared. Let's rewrite this x plus 8 squared so we can expand it. So x plus 8 squared is the same as saying x plus 8 times x plus 8. and then we want to FOIL that out. So we're going to multiply each part together. So x squared plus 12 squared is 144. So x squared plus 144 equals, so x times x is x squared plus 8 times x is 8x plus 8x plus 64. And if we simplify this, let's combine our like terms. And we can get rid of these x squareds. So since we have x squared on both sides, right, we can subtract x squared from both sides. Those go away. And we can subtract 64. We get 144 minus 64 is 80. This part goes away. And then we can combine these like terms. So 80 equals 16x. Divide both sides by 16. And we get x equals 5.